Okay, guys, so we'll get started here on lesson 2, or actually lesson 3. Lesson 2 is the climatograms activity that we're not doing. So now we're on lesson 3. Don't think I skipped. I did skip. Okay. So what we're going to look at here is some stuff related to the climate stuff we just talked about, but now it's going to be from an energy perspective. Where does the energy come from? Okay, how is it transferred? What are the mechanisms by which energy is transferred? Why do we do a lot of the things that we do, okay, in terms of energy? All right, so this is going to be very much a practical application type of lesson. I'm going to tell you about some of these things, and then we're going to look at ways that we use them, okay, why we use them, how we use them, that kind of stuff. Okay, so first thing we're going to look at the 3 parts of the Earth, because the 3 parts of the Earth are the big things that influence how energy is absorbed, reflected, okay, or like transmitted, okay, stuff like that. How does energy from the sun interact with the Earth? The parts of the Earth are how that essentially works. So it's either absorbed, absorbed, reflected, or converted. Okay, those are basically the 3 things that can happen to light when it strikes the Earth's surface. If it's absorbed, then the energy of that area goes up and it usually gets warmer. If it's reflected, it just bounces off, doesn't really have any effect whatsoever. If it's converted, that means the light is transformed into some other form of energy. And there's only one group of organisms on Earth capable of doing that. What are they? Only organisms that can harness the sun's energy directly. Plants. Yeah. Photosynthesis is the mechanism that converts solar energy into the natural process that converts it into usable chemical energy as food. Okay. Obviously, we have technology that can do the same thing, solar panels, stuff like that. Okay, we need to look at how energy on Earth is absorbed, used, and reflected, and understand how the energy and the Earth interact to produce the conditions necessary to support life. Okay, the first part of the Earth that energy from the sun interacts with is the atmosphere. Okay, it is also the most important layer of the Earth in terms of capturing that energy, transferring that energy, protecting us from that energy, okay, all of that kind of stuff. So the atmosphere is this blanket of gases that surrounds the Earth, okay? It's got different layers. I'm never going to ask you about the layers, okay? So even though this diagram has all the layers, you're not going to have to know the layers, okay? Just going to talk about kind of how the Earth's atmosphere works in terms of how it interacts with the energy from the sun. Okay. First part of the atmosphere is like the exosphere. So the first part that the solar radiation will encounter is the exosphere. That's kind of where our magnetic field lies. The magnetic field of the Earth is caused by the fact that the Earth has a big solid iron core, okay, that rotates and spins and creates a big magnetic field that acts like a big giant shield. Okay? In fact, if you've ever watched any science fiction, especially Star Trek, where they have shields that protect them from everything, that's what the Earth has. The Earth has this big shield that protects it from the really harmful stuff that the sun spits our way. That would be X-rays, gamma rays, ultraviolet rays, things like that. Those are typically deflected by the Earth's magnetic field. Okay? And sometimes we can even see the Earth's magnetic field doing its job. Okay? What does it look like when we see that?
Northern Lights.
That's the Northern Lights. Yeah. Okay? So if you've ever seen the Northern Lights, the Aurora Borealis, okay, that is what happens when high energy particles from the sun strike the Earth's magnetic field. They hit the Earth's magnetic field and they're slowed down by it. When they get slowed down, they glow. Okay? And that energy is released as visible light. Because we can't actually see a lot of the light that the sun spits our way. Okay? We can't see gamma rays. We can't see X-rays. We can't see microwaves. We can't see infrared waves. Okay, all of those things are beyond the visible spectrum, but they're still things that hit the Earth.
If you wanted to see northern lights, how would you do that then? Because you have to wait for the sunbeams to hit the Earth?
Well, you got to wait for the right kind of conditions from the sun if you're going to see them this far south. Right? If you're further north, if you're in Fort McMurray, those kind of places, you see them a lot more often because, they're faint most of the time. Okay, but you can see them up there just because you're further north. If we see them down here, it's usually because there's been some sort of coronal mass ejection. Okay, some sort of big solar storm that has spit a bit of extra stuff our way on that during that particular time. Okay, and when these solar storms happen, it can actually have an effect on our technology. Okay? It can sometimes overload power grids, disrupt cell phone communications, radio communications, things like that, because those things rely on the Earth's magnetic field being fairly static. And when it's protecting us, it's taking a lot of abuse, and it can really interfere with how those things operate. And some of those things will get through. And if they get through, they can actually induce a current in power lines. Okay, so these high energy particles from the sun can strike our power grid and actually induce currents that are really, really high and can blow out parts of the power grid. Yeah. Okay. It's kind of like how EMP works. If you've ever heard of an electromagnetic pulse weapon, okay, it's usually the result of a nuclear detonation, but all the radiation that gets emitted can overload the power grid. Okay, so it's the layer of gases. Okay, this is where we're generally protected from. The thermosphere, and that's where your auroras and stuff can be seen. Okay, the layer that's most important for us in terms of energy transfer and storage and weather and stuff like that is the troposphere. Okay, the troposphere is the layer in which we live. It extends to about, let's say the top of Mount Everest would be kind of right at the top of it. Okay, in fact, it would probably be a bit outside of it. Beyond that height, there's not enough atmospheric pressure, not enough weight from the gases above to essentially sustain life. Okay, it's why climbers often call the tops of the big mountains the death zone. Okay, you cannot survive there long term. Okay, you can go up there, get to the top of the mountain, come back down. As long as you're not there for too long, you'll live. Okay, but you cannot live there. Okay, the atmospheric pressure is too low, there's not enough oxygen, it's obviously cold, okay, things like that. So we like to be down lower in the troposphere, okay, where conditions are good. Okay, and in that troposphere, okay, there's all kinds of stuff there that makes life possible for us and allows for the transfer of thermal energy from one place to another. So the atmosphere, because it's gas and thus fluid, can move. Okay, and it moves all the time. We detect that as wind. Those movements are the result of unequal distribution of solar energy. And so as a result, okay, we get movement of air, okay, and energy transfers. Okay, everybody all right with that? Okay, so the atmosphere, like we said, plays a critical role in maintaining the Earth's temperature, which has a profound effect on Earth's climate. And much of our incoming solar radiation is reflected away from the Earth by particles in the atmosphere. So, believe it or not, even though it seems like a lot of the sun's energy reaches the Earth's surface, actually a lot of it gets reflected away. Okay, especially the non-visible parts. Okay. So, when we got incoming solar radiation, okay, some of it is absorbed by water vapor and gases in the atmosphere. Any energy that gets absorbed results in an increase in temperature. So absorption is good. Okay? We want some of the energy to be absorbed because that helps get the temperature where it needs to be. Some of it just gets backscattered. Okay? That means it hits the Earth's atmosphere and basically just gets not so much reflected. It is a type of reflection, but not like a mirror. It doesn't like bounce off and they all go the same direction and we could see a reflection. It gets scattered, which means it gets reflected randomly. And especially this happens with blue light, which is why the sky is blue. Okay? The sky is blue because our atmospheric composition scatters blue light. Okay? So we get typically blue skies when we can see them. Now, this summer, and in other summers where we've had a lot of forest fires, what color is the sky? Yeah. Okay? It's pink or orange, okay, or some other shade, not blue. Reason for that? Particulates, like smoke and stuff like that, scatter orange and red, which is why at sunset and sunrise, the sky is typically red or orange. Closer to the Earth's surface, there's more particulates, smoke and things like that, that scatter different wavelengths of light. Okay, so they cause the sky to be different colors. Okay, does that make sense? Because I know somewhere along the way somebody told you that the sky is blue because it reflects off the ocean. Guys, the ocean is clear. Okay? The ocean looks blue because it reflects the sky, not the other way around. Okay, just so you know. Okay? The sky is blue because of backscattering. The ocean looks blue because it reflects the sky. Okay. So we got that backscattering, we got some water being absorbed, we got some being, some energy, sorry, being absorbed, some being reflected by clouds. Okay? And then we've got stuff that hits the Earth, gets absorbed by the Earth, and some that gets reflected. Now, not all of that reflected light goes right back out into space. Some of it gets trapped, okay, and reflected back down to the Earth's surface again and again in what we call the greenhouse effect. Now, you've all been told probably that the greenhouse effect is really, really bad. It's not. Without any greenhouse effect, Earth would be really, really cold. Now, I'm not saying like an increasing greenhouse effect is good. It's not. Okay? We wouldn't want the greenhouse effect to get worse because then obviously Earth would get hotter. We don't want to turn into Venus. Okay? But at the same time, without a greenhouse effect, Earth would not be able to trap enough heat to be warm. Okay? Case in point, Mars. Okay? Mars' atmosphere is not thick enough to generate a greenhouse effect, thus it can't trap any heat, thus it's very, very cold. Okay? So we want to have some greenhouse effect. Do we want it to get out of control? Absolutely not. Is it getting that way? Yep. Okay, we got to make sure we're on top of that. Okay? Now, the amount of energy that is absorbed by the Earth is affected by what the Earth looks like. Okay? This is something we call albedo. Okay? The reflectivity of the Earth's surface is called albedo. It's an important term, so make sure you highlight it or circle it. If something is highly reflected, it has a high albedo. If it is not reflective, it has a low albedo. So in the summertime, okay, here in Okotoks, we'll say 70% of the incoming solar radiation is absorbed by the Earth's surface. And the reason for that is the Earth's surface is dark in color. Okay? Grass is growing, dirt is exposed, rocks are exposed, things like that, and they absorb the sun's solar radiation. About 10% gets reflected off of water bodies, and about 20% gets reflected. So we get 70% here getting absorbed and 30% bouncing off in the summertime. In the wintertime, when the surface of the Earth is covered in snow here, snow is white, just in case you didn't know. Okay? White is the most reflective color. It has the highest albedo. So as a result, in the wintertime, 85 to 90% of incoming solar radiation reflects off the snow and is not absorbed. Okay? This is one of the reasons why climate change and global warming are a thing. Okay? As glaciers shrink, the amount of highly reflective ice that is present is reduced, and more of the Earth's surface is exposed to absorb more energy, and thus the Earth's temperature goes up. So as glaciers recede, naturally the temperature continues to increase. If we were to have an ice age, okay, and glaciers were to expand again, then there would be a higher albedo, more reflectivity, and the Earth would cool. Okay, so typically, in our wintertime, temperatures are going to be cooler because we're not absorbing a lot of solar radiation. Now, when it gets snowy, what do we put on the road? Sand. Yeah, sand and salt, right? Okay, now, why do we put the sand on there? Why do we put sand on the road? Okay, it's partially a traction thing, but not for the reason you think. Like we all think, oh, well, if there's sand there, there'll be better traction. There is to an extent. But if I put dirt on top of the snow, it's going to absorb more energy. Okay? If I darken the snow by making it dirty, it'll absorb more solar energy. If I add salt to that mix, I lower the melting point of the ice. Therefore, I make it easier to melt the snow and improve traction in the intersections where I've put the sand and salt mixture. Okay? That's the reason why we do it. It's also the reason why we make our roads dark in color. Okay? We make them out of asphalt that is typically dark, like black. Okay? Blacktop. It absorbs more solar energy and thus melts snow off of it more quickly. If you go to different places, okay, go down to California, they build their roads out of concrete. It's much lighter in color. You don't want to have blacktop in like Arizona and California. It gets so hot that it gets soft. Okay? And we actually see that here in the summertime. Okay, our asphalt does. It gets soft, and you get the grooves in the intersections. When big heavy trucks are there, they can squish it down. Okay, that problem is huge in places like Arizona and California. Okay, like I remember when we were a kid, we had a flat tire, and my dad pulled the jack out. We were down in California with our truck and camper, and he tried to jack up the truck, and the jack sank. The weight from the truck on the jack actually caused it to sink into the pavement. I'm not saying like it swallowed it up, but like sank in at this point. Okay, so it's a big deal, and so albedo can help to increase temperature or affect the amount of radiation that is absorbed. Okay, so we're going to leave it there for today. And tomorrow we're going to continue on that. Tomorrow's going to be a lot of me talking and you listening. I'm sorry about that, but we're short on time now. Okay? So, hey, I'm going to come around and spray off your desk, so get them clear, please. Everybody's got to have their mask up while I do that. Make sure you sanitize your hands on the way out. Okay? Take care of each other. Wear your masks. Okay, all that good stuff.